Hey students, this is lesson 2-3, solving multi-step equations. You're going to learn how to solve multi-step equations in one variable. Go ahead and do the review here. I'll check back with you. All right, so the idea here is that to solve a complicated equation, what you can do is keep using the properties of equality and the properties of a real number to make that equation simpler until you get it down to an equation where you just have, it's a solution equation where it just says like x equals something. Okay, so think about using the different properties of equality here on this one. So one thing I notice here is that we have like terms 8x and minus 6x. And if I just use the commutative property here and switch around the plus 5 and the minus 6x, then if you remember, when you have the same factor in two terms, you can use the distributive property and write that as a difference times that factor. And we get this. And 8 minus 6 simplifies to just 2x. Plus 5 equals 25. And then I'm going to use subtraction property of equality here, and I get 2x equals 20. And just dividing 20 by 2 gives me x is equal to 10. So the different properties we use there, we use the commutative property here, the distributive property there. We simplified, we subtracted, and then we use division to get that result. All right, go ahead, you try that. So again, I skipped some steps here, but notice that instead of showing the distributive property here, I just simplified that to 5m. So I just combined the like terms there. And I didn't show where I was adding 8 to both sides here, and where I was dividing both sides by 5 to get the result m equals 6. All right, so sometimes when you write an equation for a problem, you may have to use a little more of the properties to get the answer to that equation. So here we have Jason bought 5 movie tickets and a bag of popcorn. Jeremy bought 2 movie tickets. They spent $54 total. So what I'm thinking is we have Jason, how much Jason spent at the movie theater, plus how much Jeremy spent at the movie theater, and the total is 54. So I really have some kind of a mathematical statement going on here. So if I can represent what Jason spent and what Jeremy spent, I can get an equation out of this. And one constant is the price of the ticket, so let's just let T be the price of one ticket. Then we can represent what Jason spent, since he bought 5 tickets, as 5 times T. And he bought an extra thing of popcorn, and that's $5. And Jeremy just bought 2 tickets, so that would be 2T. And the total is 54. And now we have like terms. And I'm not going to show the commutative property here, but just know that if you have the same variable, you can just combine the coefficients, the 5 and the 2, to make 7. T plus 5, and that totally makes sense here because together they bought 7 tickets. Now I'm going to use the subtraction property of equality and subtract 5 from both sides, and I get the 7 tickets cost 49, which also makes sense because if you take away the cost of the popcorn, the $5 from the total, you have just the 7 tickets. And then I'm going to divide that by 7 and get the cost of 1 ticket. So my answer is $7 per ticket. All right, you try that. Again, notice here that, so we combine like terms, the 2C and the 2C, and just made it 4C. And I did some properties here that I didn't show. I subtracted 16 from both sides here, and I divided both sides by 4 here. And I'm going to be skipping showing that work as we go on here. But notice we just kept simplifying the equation until we got it to the solution equation, c equals 14. All right. You can also use the distributive property when solving an equation. So here, notice we have 12 times the quantity 3 minus x, and we want to get rid of that parentheses if we can. And the way we're going to do that is by using the distributive property and just multiplying 12 times 3, which is 36. 12 times x is 12x equals 60. Remember that subtraction is adding a negative. Now I'm going to subtract 36 from both sides. And I get negative 12x equals 24. Divide both sides by negative 12. And I get x equals negative 2. One thing I haven't done on this one yet is check the answer. Let's just check to make sure that's right. So I'm going to substitute negative 2 in for the x. And just make sure that it equals 60. And 3 minus negative 2, that's 5. And 12 times 5 is 60. So that's good. Go ahead, you try that. All right, so there's those answers. Now, let's think about another way to solve that, and I kind of like this way better, and see if you don't also. Notice we're multiplying by 3 here, and one way to undo multiplication is by dividing. And let's see what happens when we divide both sides by 3 here. Then we get 6 equals, and 3 divided by 3 is just 1, and 1 times anything is just that number, which is 2x minus 6. Then I can just add 6 to both sides, and I get 12 is equal to 2x. Divide both sides by 2, and I get x equals 6. I like that one better. It seems like I'm eliminating a step when I do that. All right, sometimes you'll have to deal with fractions and equations, and there's a couple ways you can do that. One way is just to find a common denominator, and the lowest common denominator here would be 8. So I'm going to rewrite both these using that denominator. And 4 times 2 is 8, so I'm going to multiply 3x times 2 on the top. That makes 6x. And so now I have that. Now I can rewrite it as 6x minus x over 1 denominator of 8. And then undoing this, I want to multiply both sides by 8. That cancels that. And I get 6x minus x equals 40. 6x minus x, that simplifies to 5x, combining like terms. And I know that x times 8 is 40, so my solution is x equals 8. Now another way we can do that problem is to eliminate the fractions. And what I mean by that is multiplication property of equality allows us to multiply both sides of an equation by any number we want. And if we have a number that's split up into fourths, like this term, and a number that's split up into eighths, like this term, if we multiply by a certain number, we can eliminate those parts. And the thing we want to multiply by is the lowest common multiple of the denominator. And that's 8. So I'm going to multiply this side by 8, and this side by 8, and that's 40. And see what happens when we do that? When I multiply 8 times 3, I get 24, and when I divide that by 4, I get 6x. When I multiply 8 times x, I get 8x, and I divide that by 8, I get 1x. And notice how I eliminated the fractions really quickly by doing that. And of course, 6x minus 1x is 5x, and 5 times 8 is 40, so my solution is x equals 8. All right, I think you should try that here, see how you do. So I chose to multiply both sides by the lowest common multiple there again. All right, one last thing that you're going to learn how to deal with is decimals. And again, one way to make the problem a little easier to deal with is if you can eliminate the decimals. And remember that that decimal is really the fraction tenths. This decimal is the fraction hundredths, and so is this. So if I multiply everything by 100, I will eliminate the decimals. And I'll show you how that works here. I'm going to multiply both sides by 100. Now 100 times 2.3, that's 230. 100 times 5 hundredths is just 5x. And 4 and 80 hundredths times 100 is 480. Remember, that's adding a negative. Subtract 230 from both sides. And I get negative 5x is equal to 250. Divide both sides by negative 5. And I get x equals negative 50. Go ahead, you try that. Do the lesson check. And all right, here's your last answer. Go ahead and do the lesson check to see if you understand what's happening here, and I'll see you in class.